dear students, welcome back. Today in this video lecture we are going to discuss the concentration and different methods to express the concentration. So before starting with this concentration and methods for calculation of concentration, let's define what is the meaning of concentration. Normally when we make a solution, we mix solute and solvent. Solute is the one which is present in small quantity, and the one which is present in larger quantity is known as solvent. So we mix solute with solvent and prepare a solution. The strength of solution is basically defined in terms the quantity of solute present in the solution. So this strength is defined as the concentration. So whenever we talk of concentration, we define the quantity or the amount of the solute present in a given solution. So this is the meaning of the concentration. And now we have how to define the concentration of solute in a given solution. So we have this concentration So now we are going to define different types of concentration. So first, look at this. One of the most important and the most commonly used form of defining concentration is molarity. Now, molarity is defined by this capital M. So capital M is not the molar mass but the molarity of the solution. Now by definition, this molarity is defined as the number of moles of solute present in a given volume of solution. The volume of solution is defined in terms of liter. So simply saying, how many moles of solute is present in 1 liter of the solution, that is defined as the molarity. So therefore, we define this molarity capital M as number of moles of solute divided by total volume of solution, and this is defined in terms of liter. So number of moles of solute by N, total volume of solution in liter. So this N by V, number of moles of solute divided by total volume of solution, this is what we call as molarity of the solution. Now let's see, this molarity is defined as moles per liter of solution. So its unit is mole per liter. So these mole per liter is sometimes known as molar. So whenever the unit of concentration is molar, means this is defined in terms of molarity, unit is mole per liter. Now we also know this number of moles can be expressed in terms of mass and molar mass. So therefore look at this, this is mass of solute divided by molar mass of solute divided by volume of solution. So if mass is given, then to define this concentration we have to convert this mass into number of moles. So divide this mass by molar mass, so this gives you number of moles, and divide this by total volume of solution, that gives you the molarity of solution. So this W by M, molar mass, that is number of moles. Now if you look at this equation very carefully, we have this molarity is equals to number of moles by volume. So therefore, number of moles is equals to molarity into volume. So the concentration expressed in terms of molarity multiplied by total volume of solution gives you the total number of moles of the solute present. If this is the total number of moles, then we can also define what is the mass of the solute. So number of moles is mass divided by molar mass. This is molarity into volume. So therefore, mass present is equals to molarity into molar mass into volume. That means this is the way how to convert moles into molarity, how to convert molarity into moles, and molarity into mass or mass into molarity. Now look at this equation carefully. This is defined as number of moles per unit volume. So volume is a term which depends on the temperature of the solution. If you increase the temperature, volume expansion takes place, concentration in terms of molarity will decrease. If you decrease the volume, contraction of volume takes place. If the volume decreases, the concentration defined in terms of molarity increases. That means the molarity as a method of expressing the concentration is a temperature dependent. Why temperature dependent? Because volume is temperature dependent. So if you increase the temperature, molarity decreases. If decrease the temperature, molarity increases. So this molarity is a temperature dependent. That is, molarity is inversely related to temperature. Why? Volume is dependent on temperature. Increase in temperature, volume increases, molarity decreases. Decrease in temperature, volume decreases, molarity increases. So this is how we define molarity. Molarity, number of moles per unit volume temperature dependent, so concentration is temperature dependent. Molarity, to define this number of moles, if mass is given, then convert this mass into number of moles. Or if question says find the number of moles in a given solution with concentration, then we have this relationship. This is molarity. Now let's explain this by taking an example. Suppose 4 gram of sodium hydroxide is dissolved in 250 ml of water. What is the molarity of the solution? So question says we have a sample of sodium hydroxide whose mass is given as 4 gram. So 4 gram of sodium hydroxide is dissolved in 250 ml of water. So what is the molarity of solution? Now mass of sodium hydroxide is given as 4 gram. Its molar mass is 40 gram per mole. Total volume of solution is 250 ml. So this is 250 into 10 to the power minus 3 liter. Now we have this relationship. Molarity is mass divided by molar mass divided by volume. So therefore, molarity of the solution is W by molar mass divided by total volume of solution. So mass is 4 gram divided by 40 into 10 to the power minus 3. So this comes out to be 4 into 10 to the power 3 divided by 40 into 250. So this is the molarity. So this is mole per liter, or simply say molar. We can also simplify this. This is 4 into 10 to the power 3 divided by, this comes out to be 10,000. So it is 0.4. So This is 0.4 molar. So 4 grams sodium hydroxide in 250 ml of water is equivalent to 0.4 molar. So this is how we define molarity. One question: concentration of glucose in blood is 90 milligram per liter. Concentration of glucose in blood is 90 milligram per, so this is per 100 ml. What is the molarity of, so we have a concentration of glucose present in blood is approximately 90 milligram per 100 ml. What is the molarity of solution? So 90 milligram is present in 100 ml. So mass of glucose is 90 milligram. So this is 90 into 10 to the power minus 3 gram. Molar mass of glucose, this is 180 gram per mole, and volume of blood, this is given as 100 ml, or this is 100 into 10 to the power minus 3 liter. So therefore, molarity of this glucose present in blood, this is number of moles divided by volume, that is mass divided by molar mass divided by volume. So mass is 90 into 10 power minus 3, molar mass is 180, volume is 100 into 10 to the power minus 3. So this cancels out. So this is 0.5 into 10 to the power minus 2, 0.005 moles per liter of the solution. So 90 milligram per 100 ml of glucose in blood is corresponding to 0.005 molar solution. Let me take up one more question. A commercial sample of HCl, commercial sample of HCl is designated as 12 molar. A commercial sample of HCl is designated as 12 molar. Question says, how many moles and grams of HCl is present in 300 ml of 12 molar solution? So we have a sample of HCl. So this HCl is given as 12 molar. So the concentration is given as 12 molar. Now question says, In a 300 ml of this 12 molar solution, how many moles of HCl is present and how many grams of HCl is present? So question says molarity, that is 12, volume of solution is given as 300 ml. Now this is 300 into 10 to the power minus 3 liter. Question says how many moles of HCl is present and how many grams of HCl is present in this 300 ml. Now first of all, look at this. We have definition of molarity says this is number of moles per volume. So therefore number of moles is molarity into volume. So this molarity is 12, volume is 300 ml. So this comes out to be 3.6. So 3.6 mole is present in 300 ml of 12 molar solution. Now look at this. This number of moles is defined as mass by molar mass. Therefore mass is equals to number of moles into molar mass. Number of moles is 3.6. Molar mass of HCl is hydrogen is 1, Cl is 35.5, that is 36.5. This is the gram of HCl present in 300 ml of 12 molar solution. So this is a basic term to define the concentration in terms of molarity. So how we can convert this moles into molarity, mass into molarity, or molarity into moles, and molarity into mass. So this is one of the most common method of concentration used in chemistry. Now next method for expression of concentration is molality. Second one is molality. Designated by small m. So we have a second concentration term, that is molality. The first one is molarity. This is molality. Now let's just define this molality first. Molality is defined as number of moles of solute present per kilogram of solvent. That means how many moles of solute is present in 1 kilogram of solvent, that is defined as the molality small m. So we have this molality. This is defined as the number of moles of solute divided by mass of solvent, and this mass of solvent must be taken in terms of kilogram unit. So we have to look at this moles of solute divided by mass of solvent taken in terms of kilogram. So this moles per kilogram, this is defined as the molality. So we have to look at this is number of moles divided by mass of solvent, and this mass must be taken in terms of kilogram. So if you look at this, so this mass, there is mass of given solute divided by molar mass divided by mass of solvent. This mass of solvent must be taken in terms of kilogram unit. But if you are taking the mass in gram, molar mass in gram, this doesn't make any difference because this comes out to be a simple ratio. So look at this. Molality is moles per kilogram of solvent. So its unit is mole per kilogram. So mole per kilograms is simply written as molal. So concentration in terms of molality is molal, that is mole per kilogram of solvent. So but if the mass, this is mass in kilogram, but if the mass is taken in gram, so this can be written as W into 1000 divided by molar mass of solute into mass of solvent taken in kilogram unit. So definition says this is to be expressed in terms of kilogram. Now if you look at this expression of this molality, number of moles divided by mass of solvent. Number of moles is temperature independent. Mass is again temperature independent. So this method of concentration, that is molality, is independent of concentration temperature. Independent of temperature. So if you change the temperature by heating or by cooling, this won't have any effect on the molality. Whereas molarity changes with temperature, but molality does not change with temperature. So this is molarity expression, unit for molarity in terms of mass and temperature dependent. Now, these molality and molarity is related to each other. So, relation between molarity and the molality. So, we have to find the relation between molality and the molarity of the given solution. So, molarity small m is equals to 1000 times capital M divided by 1000 times D minus capital M small m prime. What is capital M? This represents molarity. Small m prime, this represents molar mass of solute, and this D represents density of solution in gram per ml. So 1000 times molarity divided by 1000 times density of solution minus molarity into molar mass of solute. This is equals to the molality. So we can convert molarity into molality and molarity into molarity, provided we know the density of the solution. So let's take up some examples to define this term called molality. Question says density of 3 molar NaCl is 1.25 gram per ml. Calculate molality of the solution. So question says we have a sample of NaCl whose concentration is expressed as 3 molar. Density of solution is 1.25 gram per ml. Then what is the molality? So we have molarity, density, and we have to define molality. So we have this relationship. Molality is equals to 1000 m divided by 1000 d minus m into m. So we get this direct relationship here. Molality is equals to 1000 into molarity divided by 1000 into density minus molar mass into molarity. So 1000 into molarity. Molarity is 3. Density 1000 into 1.25 gram per ml minus molarity is 3. Molar mass of NaCl, sodium is 23, chlorine is 35.5, so this comes out to be 50.5. So this is molar. So conversion of molality to molarity, molarity to molality, this is through density of solution. So density of solution should be known to convert this molarity into the molality. So this is how we define molarity of solution. Let me give you one more example. 4 grams of sodium hydroxide is dissolved in 100 grams of water. Find the molarity of sodium hydroxide. So question says we have 4 grams of sodium hydroxide. These 4 grams of sodium hydroxide is dissolved in 100 grams of water. So find the molarity of sodium hydroxide. So mass of sodium hydroxide is 4 grams. Molar mass of sodium hydroxide, it is 40 gram per mole. Mass of water, that is solvent, that is 100 gram, or this is 100 into 10 power minus 3 kilogram. So therefore, molarity is number of moles divided by mass of solvent taken in terms of kilogram. So this is mass by molar mass divided by mass of solvent. 4 divided by 40 into 100 into 10 to the power minus 3. So this is 4 by 4, or we say 1 molar. So 4 grams of sodium hydroxide in 100 grams of water is equivalent to 1 molar solution. So this is how we define molarity of a solution. Now after this, we have third concentration term, that is percentage. Concentration expressed in terms of percentage. So now under this percentage, we have different methods to express percentage. First one is percentage by mass of solution. Percentage by mass of solution. So percentage by mass of solution, this is defined as mass of solute divided by total mass of solution multiplied by 100. Mass of solute divided by total mass of solution multiplied by 100 is defined as a percentage by mass of solute in solution. So look at this, we have a mass is temperature dependent. This is again mass is temperature dependent. So percentage by mass of solution is temperature independent. Again, this is a ratio of mass, so this doesn't have any unit. Temperature independent. So if mass of solid is W1, total mass is W1 plus W2, and mass of solute, mass of solvent. Solute plus solvent, that is total mass multiplied by 100. So this is mass fraction. Second, percentage by mass of solvent. This is percentage by mass of solution. Next is percentage by mass of solvent. The only difference is instead of total mass of solution, this must be taken in terms of mass of solvent. So we say this is mass of solute divided by mass of solvent into 100. So mass of solute, that is W1, mass of solvent, that is W2, multiplied by 100. So in a given volume, in a given mass of solvent, how many mass of solute is present? It is defined as mass by solvent, sorry, percentage by mass of solvent. Again, both numerator and denominator is mass, so this is unitless, and mass is independent of temperature, so this is again temperature independent. Next method for defining percentage, it is percentage by volume of solution. Percentage by volume of solution. So percentage by volume of solution is same as that of mass, except that instead of mass we have to taken volume. So this is volume of solute divided by volume of solution into 100. Numerator is volume, denominator is volume. Volume ratio unitless, so this is unitless quantity. Second thing, volume is a temperature dependent quantity. So on increasing temperature or decreasing temperature, expansion of volume or contraction of volume takes place. So volume being temperature dependent, this percentage by volume of solution is a temperature dependent quantity. So we have percentage by volume of solution. Next, volume per mass. Percentage volume by mass of solution. So percentage volume by mass. So this is nothing but volume of solute divided by mass of solution into 100. So in a given mass of solution, what is the volume of solute? The volume of solute divided by mass of solution into 100, that defines a quantity which is known as percentage volume by mass. Now volume is unit, mass is having a different unit, so this is a one having some unit. Volume is temperature dependent, but mass is temperature independent. So these term, percentage mass by volume or volume by mass, this is temperature dependent quantity. When we have concentration expressed in terms ppm, parts per million, ppm, 1 million stands for 10 to the power 6. Now these parts per million is used for defining concentration which is extremely small, like the concentration of pollutants in air. This is always defined in terms of ppm or parts per billion. So these parts per million means in 1 million of the sample, what is the mass of solute present? So mass of solute present in 1 million mass of the sample, that is defined as parts per million. So normally this ppm is defined as mass of solute divided by mass of solvent into 10 to the power 6. This is defined as parts per million. It is in terms of mass fraction or mass of solid divided by total mass of solution into 10 to the power 6. Or another form of expression of this ppm is also defined as mass fraction into 10 to the power 6. This is nothing but the mass fraction, which is equals to mass percent into 10 to the power 4. Fraction into 100 is percentage. Another form of expression of this parts per million, this is mole fraction into 10 to the power 6. This is also equals to mole percent into 10 to the power 4. That means parts per million can be expressed in terms of mole fraction or in terms of mass fraction. So if ppm is given and question says find the mass fraction, you can use that relationship. This is mass fraction. Or if question says mass percentage, convert this ppm into mass percentage, then also we can convert it to ppm by this relationship. Or if mole fraction is given, then also we can find the parts per billion. Or if ppm is given, then also we can define what is the mole fraction of solute or what is the mole percentage of solute. So this is parts per million. Or sometimes parts per billion is also given. Parts per billion. B for billion, then to the power 9 parts. This is much smaller compared to that of parts per million. So these parts per million and parts per billion is used for defining very small concentration terms that I have given you, like just for expression of air pollutants present in air. So this is in terms of parts per million or parts per billion. So these are some of the methods by which we can also define percentage. Based on this, let's discuss some problem. Suppose a sample of drinking water is contaminated with chloroform. A sample of drinking water is contaminated with chloroform. The concentration of chloroform in the sample is 15 parts per million. So we have a sample of drinking water. This drinking water is contaminated with chloroform CaCl3, and the concentration of chloroform in the sample is 15 parts per million. Question says express this in mass percent. Second, find the molality of solution. So first is express these 50 parts per million into mass percent, and then finally question says what is the molality of chloroform in the sample. Now first we have a mass percent, we have ppm, the relation is here. So ppm is equals to mass percent into 10 to the power 14. So we have this ppm is equals to mass percent into 10 to the power 4. Therefore, mass percent is equals to ppm into 10 to the power minus 4. So it is 15 into 10 to the power minus 4. That means 15 into 10 to the power minus 4 gram of chloroform is present in 100 gram of solution. Now the second part is to define the molarity. Says 15 into 10 power minus 4 gram is present in 100 gram of solution of water. So we have mass of chloroform. Therefore, mass of chloroform is 15 into 10 to the power minus 4 gram. Total mass of solution is 100 grams. So 100 minus this way, that is extremely small. So therefore, mass of solvent, that is water, is approximately 100 gram. You can also take exact value 100 minus this value, that is approximately 99.99 something, which is equivalent to almost 100. Therefore, number of moles of chloroform is equals to mass divided by molar mass. Mass is 15 into 10 to the power minus 4. You can define molar mass. Carbon is 12, hydrogen is 1, chlorine is 23.5. So we have 3 chlorine, 1 hydrogen, 1 carbon. Summation of this atomic mass gives you the molecular mass. So this is, that is the M. So we have number of moles. So to define this molality, we have number of moles divided by mass of solvent. So molality is number of moles divided by mass of solvent into, so number of moles is 15 into 10 to the power minus 4 divided by molar mass. Mass of sample is solvent is 100, that means 100 into 10 to the power minus 3 kilogram. So this is a molarity of sample whose concentration is given as 15 parts per million. Now let's take some more example here. Question says an aqueous urea solution is 20% by mass. An aqueous urea solution is 20% by mass. What is, or calculate percentage by mass of solvent. So we have an aqueous urea solution which is 20% by mass of solution. Now we have to express this in terms of percentage by mass of solvent. So if you look at this, 20% by mass of solution, that means 20 gram of urea is present in 100 gram of solution. So 20 gram of urea is present in 100 gram of solution. So therefore, mass of water is total mass of solution minus mass of solute. So that is 80 gram. So mass of solid is 20 gram, mass of solvent is 80 grams. So therefore, percentage by mass of solvent, that is mass of urea divided by mass of water into 100. So urea is 20. So this is the percentage by mass of solvent from this percentage by mass of solution. question says 1 gram of ethanol, methanol with density 0.75 gram per ml is mixed with 1 gram of water whose density is 1 gram per ml. What is the volume percent of methanol? So question says the solution is formed by mixing 1 gram of methanol in 1 gram of water. Densities are given. So what is the volume percent? So we have a density, we have a mass. So this is to be converted into volume. So we have mass of methanol is 1 gram. Density of methanol is 0.75 gram per ml. So therefore, density is given as mass per unit volume. So therefore, volume is equals to mass by density. So mass is 1, density is, so that is 1.33 ml. Similarly, volume of, this is volume of methanol. So therefore, volume of water is again mass of water divided by density of water. Mass of water is 1, density of water is 1 gram per ml. So this is 1 ml. So therefore, total volume, that is volume of methanol plus volume of water, that is 1.33 plus 1, that is 2.33 ml. Now therefore, volume percent of methanol is volume of methanol divided by volume of solution into 100. Methanol is 1.33, total volume is 2.33 into, this is the volume percent of methanol. This question, a sample of sulfuric acid is 98% by mass of solution. So we have a sample of sulfuric acid. This is 98% by mass of solution with density 1.8 gram per ml. Expressed in percentage mass by volume of solution. So a sample of sulfuric acid which is 98% by mass of solution having density 1.8 gram per ml. This is mass by mass. Now we have to express mass by volume of solution. So first is 98% by mass of solution, that means 98 gram of sulfuric acid is present in 100 gram of solution. So 100 gram of solution, mass of sulfuric acid is 98. Now density of solution given as gram per ml. So this is the density of solution. So density of solution is 1.8 gram per ml. So we have to convert this in terms of volume. Density is mass divided by volume. So therefore, volume is equals to mass divided by density. So density of solution is 1.8 gram per ml. That means 1.8 gram is present in 1 ml of solution. So 1 ml contains 1.8. Then 100 gram कितने present होगा, that is the volume. Total mass of solution is 100 gram. Density is 1.8 gram per ml. So this is the volume. So 1.8 gram is present in 1 ml of solution. So total mass of solution is 100 grams. So 100 grams should be present in this much ml. So this is 1000 divided by 18 ml. Now we have mass of sulfuric acid, that is 98% of the value. So this is total volume. We have mass of sulfuric acid. So therefore, percentage mass by volume into this is equals to mass is 98, total volume is 1000 by 18 into 100. So this is mass by volume percent from mass by mass percentage. A simple question. We have a mixture of A and B. A, this is 2 gram, B is 18 gram. So what is the percentage of A? So first mass by 2, we are given mass, so you have to find the mass percentage. So percentage of A is mass of A divided by total mass. Total mass is 20 into 100. So this is 20%. Then percentage of B is 100 minus percentage of A. So 100 minus 20, that is 20%. So simply mass are given. That is very easy to find mass percentage. So this question says a sample of hot water contains 1 milligram of calcium chloride per liter. A sample of hot water contains 1 milligram of calcium chloride per liter. Express this in terms of calcium carbonate present in 10 to the power 6 parts of water, that is ppm of calcium carbonate. So we have a sample of hot water which contains 1 milligram of calcium chloride present in 1 liter of solution. So what is the parts per million of calcium carbonate? So if you look at this, we have to convert this calcium chloride into calcium carbonate. Number of moles of calcium chloride is equivalent to number of moles of calcium carbonate. So number of moles of calcium chloride, that is mass by molar mass. Number of moles of calcium carbonate, that is 1 into 10 to the power minus 3 divided by molar mass. Calcium is 40, chlorine 35, that is 71, so we have triple 1. So this is number of moles of calcium carbonate, which is equivalent to number of moles of calcium chloride. So we have number of moles, therefore mass of calcium carbonate is equals to number of moles into molar mass. Number of moles is 10 to the power minus 3 divided by triple 1. Molar mass is 100, so this is 0.1 divided by triple 1, or we can say 1 divided by triple 1, 0. So this is mass of calcium carbonate. Now we have to express this in terms of parts per million. So mass of calcium carbonate, that is 0.1 divided by triple 1. So this is 1 divided by 110 gram. So this is present in 1 liter. This mass gram is present in 1 liter of the solution. So we define parts per million as mass of solute divided by mass of solvent into 10 to the power 6. Solution of water is, total volume is 1 liter. So 1 liter density is 1. So we have 1 gram. So therefore ppm is 1 by triple 110 into 10 to the power. So this is parts per million when this 1 milligram of calcium chloride is expressed in terms of calcium carbonate. So this is percentage. Now once we have this percentage, the another method of expression of concentration is mole fraction. Mole fraction divided is denoted by this, pronounced as chi mole fraction. Now this mole fraction, this concentration term mole fraction is defined as in a mixture of substance, the number of moles of any given component divided by total number of moles of the solution. That fraction is defined as mole fraction. So therefore mole fraction is defined as number of moles of a component divided by total number of moles in the mixture. So moles of any given component divided by total number of moles of its components present in the solution, that is defined as mole fraction. So we have a fraction. Summation of fraction is always 1. So now look at this. Numerator is number of moles. This is also number of moles. So this is number of moles divided by total. Let this be mole fraction of component I. So number of moles of component I divided by total number of moles. So this mole by mole, this is a unitless quantity, and number of moles is temperature independent. So this is temperature independent. So mole fraction is number of moles of any given component divided by total number of moles. And summation of mole fraction is always equals to 1. That is, suppose we have mole fraction of 1 plus mole fraction of 2 plus mole fraction of 3 plus this is always equals to. So summation of mole fraction is always equals to 1. Now relation between mole fraction and molarity and mole fraction and molarity. Relation between mole fraction and molarity. So we have this mole fraction and this is molarity. So molarity is equals to 1000 times density of solution into mole fraction of solute divided by mole fraction of into molar mass of solute plus mole fraction into molar mass of solvent. So 1000 into density into mole fraction of solute divided by mole fraction of solute into molar mass of solute plus mole fraction of solvent into molar mass of solvent. Relation between mole fraction and molality. So we have this mole and molality. This is equals to 1000 into mole fraction of solute divided by mole fraction of solvent into molar mass of solvent. We have a mole fraction of solute, we have a mole fraction of solvent. So we can express in terms of mole fraction of solute. So 1000 into mole fraction of solute divided by 1 minus mole fraction of solute is equals to mole fraction of solvent. So we have this solute, this is solvent, solute plus solvent is equals to 1 into molar mass of solvent. So this gives a relation with conversion from mole fraction into molarity, molarity into mole fraction, or mole fraction into molarity, molarity into mole fraction. Now let's use this for solving problems. (4.6 gram) of ethanol C2H5OH is present in 10 gram solution. Calculate the mole fraction. So we have a solution in which 4.6 gram of ethanol is present in 10 gram of solution. What is the mole fraction of the components? So we have mass of ethanol is equal to 4.6 gram, molar mass of ethanol, carbon is 12, oxygen 16, 12, 16, 12 into 2, 16 plus 6, 24, 46. Mass of another component, second component, that is 10 minus 4.6, that is the second component, this is 5.4 gram. Ten gram of aqueous solution. So mass of water is molar mass of water is 18 gram. So therefore look at this. Number of moles of ethanol is mass by molar mass, that is 0.1. Number of moles of water 5.4 divided by 18, it is 0.3. Therefore total number of moles is moles of ethanol plus moles of water, that is 0.4. Now mole fraction of ethanol is number of moles of ethanol divided by total number of moles, which is 0.1 divided by 0.4, that is mole fraction 0.25. Mole fraction of water is 1 minus mole fraction of C2H5 OH, that is 1 minus 0.725, that is 0.7, but also you can find out that is 3.75. So this is how we find mole fraction from mass. Let's take some more examples here. An aqueous solution of glucose C6H12O6 is 36% by mass of solution. So we have aqueous solution of glucose which is 36% by mass of solution. Calculate the mole fraction of glucose. So question says mass percentage of glucose in solution is 36. Then we have to find the mole fraction. Question says mass percentage is 36. So therefore 36 gram of glucose is present in 100 gram of solution. So therefore mass of glucose, that is 36 gram. Therefore mass of water is 100 minus 36, that is 64 gram. So total mass of solution is 100. All of these 36 is glucose, remaining 64 is water. Number of moles of glucose, mass divided by molar mass. Mass is 36, molar mass is 180. Number of moles of water, 64 by 80. So we have this number of moles of glucose, we have number of moles of water. So therefore, mole fraction of glucose, that is number of moles of glucose divided by number of moles of glucose plus number of moles of water. So number of moles of glucose 36 by 180. Total number of moles 36 by 180 plus 64 by 80. So we can simplify this way. 36 by 180 divided by 36 by 180 plus 640 by 180. So 180 will cancel out. So therefore, mole fraction of glucose is 36 by 6, 7, 6. That is the mole fraction of glucose. If this is the mole fraction of glucose, we can define the mole fraction of water, that is 1 minus mole fraction of glucose, that is the mole fraction of water. Question says, mole fraction of naphthalene, mole fraction of a compound known as naphthalene, molecular mass 128 in benzene, molecular mass 78 is 0.2. So we have a mixture of naphthalene and benzene. Molecular masses are given. Mole fraction of naphthalene in the mixture is 0.2. Question says, calculate percentage concentration of naphthalene by mass of solution. Percentage by mass of solution. So we have mole fraction of naphthalene. So therefore, look at question says mole fraction of naphthalene, that is 0.2, which is mole fraction of naphthalene by total number of moles. Mole fraction of benzene, summation of mole fraction is 1. So therefore, mole fraction of naphthalene plus mole fraction of benzene should be equals to 1. So therefore, mole fraction of benzene is 1 minus mole fraction of naphthalene, that is 0.8. So this is according to definition, number of moles of benzene divided by total number of moles. So therefore, mole fraction of naphthalene by mole fraction of benzene, which is equals to 0.2 by 0.8. So this is number of moles of naphthalene by number of moles of benzene. Now, number of moles of naphthalene is mass of naphthalene divided by molar mass. Molar mass is 128. Number of moles of benzene is mass divided by molar mass. So we have this mass of benzene divided by 78. So therefore, look at this. Mass of naphthalene divided by mass of benzene mass of naphthalene by mass of benzene, that is 0.2 by 0.8 into 128 by 78, that is cross multiplication. 4. So we have this mass of naphthalene, mass of benzene. So this is 32. So we have mass of naphthalene by mass of benzene is 32 by 78. This is mass ratio. Now we have to find percentage of naphthalene by mass of solution. So the ratio is 32 by mass. Therefore, mass of naphthalene is 32 gram, mass of benzene is 78 gram. Therefore, mass of solution is 32 plus 78, that is 110. So percentage of naphthalene. So this mass of naphthalene divided by total mass into 100. This is mass percentage of naphthalene whose mole fraction is given here. So mass percentage So this is how we define mole fraction. So these are the various methods by which we define the quantity of solute present in a given solution. So we have molarity, we have molality, we have percentage, under this we have different types of percentage, then we have mole fraction. Now there is a one more thing, that is if two different solutions with different concentration is mixed, then how to find the resultant concentration of the mixture. Suppose we have a solution A plus solution B, solution A plus solution B of same solute. We have same solute and these are different two different solutions, solution A and solution B. Now solution A concentration is MA, solution B volume taken is BA. That means we have a solution A whose concentration is MA molarity, volume taken is BA liter or ml. For this solution B, concentration is MB, volume taken is VB. Then after mixing of these two, what is the resultant concentration of this solute in the mixture? Now we have concentration in volume, concentration in volume. So therefore, number of moles of solute in A is molarity into volume. So we have MBA This is number of moles of solute in solution A, molarity into volume. Number of moles of solute in B solution, that is molarity into volume of B. Now we have number of moles of solute in A, number of moles of solute in B. Therefore, total number of moles of solid is number of moles of solid in A plus number of moles of solid in B. So this is MBA plus MBB. Total volume of solution is BA plus BB because before mixing volume is B and volume B, after mixing this is total volume. Therefore, final concentration is total number of moles divided by total volume. So this is MBA plus MBB divided by BA plus BB. That means if we have different solutions of the same solute, then if they are mixed together, then the resultant solution is given as such. So convert this concentration and volume into number of moles, then find the total number of moles, then divide this total number of moles by total volume. That gives you the resultant concentration of the solute in the solution. Or if suppose we have a mixture of acids and base, so when we mix acids and base, obviously neutralization reaction takes place. So if neutralization reaction takes place, some of the acids and some of the base will be consumed. Then we have to find what is the resultant, the concentration of the acid or base left. So let's take this example 1, example A. So we have a sample of HCl solution. Aqueous HCl solution. Solution 1, solution 2. Solution 1 says this is 100 ml 0.5 molar. Solution 2 this is 100 ml 1 molar. So we have two different solutions of HCl. Solution 1 100 ml volume 0.5 molar. Solution 2 100 ml and 1 molar. So what is the concentration of HCl after mixing of these two? So number of moles of HCl in one, that is molarity into volume. Since this is ml, so we say this is millimoles. Number of moles of HCl in solution 2, that is 1 into 100 millimoles. So therefore, this is 50 millimole, this is 100 millimole. Therefore, total number of moles is number of moles of HCl in 1, number of moles of HCl in 2. So this is 100 plus 50, 150 millimole. Total volume is 100 plus 100 ml, that is 200 ml. So therefore, the molarity of HCl final after mixing, that is total number of moles of HCl divided by total volume of solution. So this is 150 millimole divided by 200 milliliter, milli cancel of moles per liter. This is the final concentration of the mixture resultant solution. Next, if we have a mixture of acids and base, then how to find the concentration of the solution? Suppose we have HCl plus sodium hydroxide, a mixture of strong acid and strong base. If acid and base is mixed, this undergoes neutralization to give you sodium hydroxide plus NaCl plus H2O. So after this, you have to find what is the amount of acid left, what is the amount of base left, or how much is reactive if both are consumed or if someone is left unreactive. So let's take this case. Acid concentration is M1, volume V1, sodium hydroxide concentration M2, volume V2. Now, when this HCl ionize to give you HCl and Cl minus, so therefore number of moles of HCl is M1V1, therefore number of moles of H plus ion is M1V1 because 1 mole HCl gives you 1 mole H plus ion. Number of moles of sodium hydroxide, that is M2V2. When this sodium hydroxide ionized, this gives you hydroxide ion. So therefore, number of moles of OH minus ion is M2V2. So there are three possible cases that may arise. Either both are equal. If both are equal, there is no acid, there is no base left. If some of the acid is left or some of the base is left. So we have cases. If number of moles of acid is greater than number of moles of base, quantity of acid is greater than quantity of base. Yes, therefore, so number of moles of H plus ion left will be number of moles of H plus ion initial minus number of moles of OH minus ion. So every 1 mole of HCl will equal 1 mole of OH minus ion. So this is number of moles of H plus ion left is initial minus the reacted. So this is M1V1 minus M2V2. Total volume is V1 plus V2. So therefore, concentration of acid is M1V1 minus M2V2 by V1 plus V2. So this is the case when acid is greater than base. Case 2, if number of moles of base is greater than number of moles of H plus ion. Quantity of base is greater than quantity of acid. That means after reaction, some of base will remain unreacted. So therefore, number of moles of OH minus ion left will be equal to initial quantity of base, that is M2V2. Quantity of base consumed by acid will be M1V1, that is M1V1. Total volume is V1 plus V2. So therefore, concentration of base, it is M2V2 minus M1V1 by V1 plus V2. If number of moles of acid, number of moles of base, then there is no acid or base left. That is 100% consumed in the reaction. So this is when we have a mixture of acids and base. So depending on the quantity of acids and base, we have to find whether the quantity is excess is acid or base, and resulting we can find the concentration of acid or base. Let's take this. This I suppose 0.5 molar and 100 ml and 0.5 molar 200 ml. So we have HCl 0.5 molar 100 ml, sodium hydroxide 0.5 molar 200 ml. Now after this, we have to find the concentration of acid or base left unreacted. So therefore look at it, number of moles of HCl is equals to number of moles of H plus ion. So this is equals to 0.5 into 100, that is 50 millimole. Number of moles of OH minus ion is equals to number of moles of sodium hydroxide, that is 0.5 into 200, that is 100 millimole. So concentration of base is 100 millimole, concentration of acid is 50 millimole. So this is the limiting reagent. So after reaction, this will be 100% consumed. This something unreacted left. So therefore, number of moles of H plus ion is less than number of moles of OH minus ion. So therefore, number of moles of OH minus ion left unreacted, that is 100 minus 50, that is 50 millimole. Total volume of solution is 100 plus 200 is 300 ml. So therefore, concentration of OH minus or base left is total moles divided by total volume. This is how we define the concentration of acid or base after mixing of the two. Then there is one more concept that is known as law of dilution. Law of dilution. Dilution means decrease in concentration by increasing the volume of solution. Decreasing the concentration by increasing volume of solution. This is what we mean by dilution. That means we have an initial stock solution. To this stock solution, we add additional quantities of solvent. So we are increasing the quantity of solvent, means volume of solvent. So increasing volume of solvent means we are increasing the total volume of solution. If total volume of solution is increased, concentration expressed in terms of molarity will decrease. So this decrease in concentration by increasing volume is what we call as dilution. So during this dilution process, what is happening is we have initial stock solution. To this we are adding some additional volume of solution. So we are just increasing the volume of solution. We are not changing the number of moles of solute. That means before dilution and after dilution, number of moles will remain same, but the concentration will change. So suppose we have a solution. This is stock solution. Whose concentration is M1, volume is V1. Now to this we add V2 of solvent. After this is converted into concentration M2 and total volume, that is V3. This is stock solution, this is diluted solution. So during this process, look at this, we are increasing the volume of solvent in this stock solution. Increasing the volume, we are not changing the quantity of solute present. So this is what we call as dilution process. So during this dilution process, number of moles of solute remains constant. So during any dilution process, only the volume is increased, but the number of moles of solid remains constant. So this is the initial concentration, initial volume, final concentration, final volume. So this volume V3 is equal to V1 plus V2. And during dilution process, number of moles of solid remains constant. So according to this law of dilution, according to law of dilution, number of moles of solute before dilution is equal to number of moles of solute after dilution. In both the case, number of moles will remain same, only the concentration will change. So before dilution, number of moles is M1 or V1. Molarity to volume, that is number of moles. After dilution, concentration is M2, volume is 3. So molarity to volume is number of moles. So this is what we call as M1 V1 equals to M2 V3, where V3 is V1 plus V2. So we simply say, so if initial concentration, volume and final volume is given, we can define what is the concentration. If initial volume concentration is given and final volume concentration is given, then we can define what is the final volume solution. So simply we say MP initial is equals to MV final. So M1 V1, M2 V3. So by use of this, we can find the concentration after dilution, and after dilution, if concentration is given, then what is the final volume and how much of volume is added to make up the final volume. So this is what we call as law of dilution. Let me give you one example for this law of dilution. It's 0.01 molar (500 ml) of HCl. A 0.01 molar 500 ml of HCl is diluted to 1 liter. This is the initial HCl sample. Now this is diluted to 1 liter. Find the concentration of diluted HCl. So we have this before dilution. So before dilution, that is M1 V1, that is initial. After dilution, we have MV final. So we have to find concentration of diluted solution. So we have M final is equals to MP initial divided by V final. So M initial is 0.01. Volume is 500 ml. Final volume is 1 liter. This is ml, so you have to convert either in terms of liter or ml. That is ml. So this is the concentration of the diluted solution whose initial concentration is 0.01. So this is 0.01 into 0.5. So this is 0.005 molar. So after dilution to 1 liter, the concentration becomes 0.005. So it was initially 0.01 molar. So this is how we define the concentration after dilution, which is what we call as law of dilution. So this is something about the concentration and how different solutions are measured in terms of their solid strength. So hopefully we enjoy this class. Thank you.